Hi everyone. Thanks for joining on a Friday morning for this super exciting topic. Let me start by sharing my screen. Just a couple of minor things. So I do have you guys open on my second screen. So I will be looking at the chat on and off. So please feel free to post or raise your hand or just interrupt, right? So this is more of a conceptual topic. So we are not going to be going like the depth of codes and stuff. So okay, so let's start. This presentation is more about Stata frames. So if you've been to my previous talks, usually I focus heavily on data visualization and stuff. But quite a lot of you that I've interacted with are coming from the research field, are doing analysis, or writing your own programs. And I also get quite a lot of code to review for publications and stuff. And I've really seen the use of Stata frames, right? So Stata frames has existed since Stata 16. So it's already 2, 3 years old. And it's not a common tool. Yeah, it's could be because people have their predefined workflows or are just used to working in a static whatever data environment. But that's why I want to go over, let's say, 3 to 4 applications of how this could benefit you guys who are coming from, let's say, what I presume is mostly the academic side, right? Yeah. So frames, the concept of frames is not new. Yeah. The concept of frames is exists in other software, so SQL, R, Python, where you start your Stata instance, and in your Stata instance, you're loading a data set, right? And that's the data set you're working with. And so if you want to load a second data set, you would replace the one you're using, right? So you would say use auto whatever, and then you will say use something else clear. So you are replacing this, right? The concept of frames is that you're holding multiple data sets in your Stata memory at the same time. And there are many, many reasons to do this, right? And we'll go over them. So the idea is that once you know of the options of how to use data frames, you can, of course, apply these to your workflows. The only limitations I think I see is that you need newer versions of Stata, so 16 plus. But let's say most of us who are also writing programs, it's a huge, huge, huge plus. If you've used maps, geoplot command or everything, it uses frames in the background. So basically you have multiple map layers stored in the background. But let's start with an example that might be more relevant to some of your work, right? So a lot of us work with multi-level data sets, which means we are working with data sets which are sort of summarizing different parts of our environment, right? So it could be patients, doctors, hospitals, yeah? It could be students, teachers, schools, right? And so this is a very common setup. So it's a common setup where you have 100,000 patients, which could be looked after by 10,000 doctors in 1,000 hospitals, right? And so if you're doing some sort of analysis, you'll be saying, okay, let's analyze 100,000 patients and look at the attributes of doctors and hospitals, right? And so what you would typically do in the old workflow environment is that you would merge everything together. So which means that for each 100,000 patients, you would say, okay, what's the doctor identifier? You would merge this data set to this data set. So you're multiplying your doctors 10 times, right? Similarly, if each patient has a hospital assigned to him or her, uh, you would assign hospital attributes and you will be multiplying the observations 100 times, right? So it could be for hospital fixed effects, doctor fixed effects, whatever, right? Or you are looking at survival rates by different hospitals. And so the And this is multiplying our observations a lot, right? And as data sets are getting bigger and bigger, you're putting together bigger and bigger data sets unnecessarily, right? So sometimes all you need to do is attach one or two key variables from this data set or a few key variables to this data set. So you don't need to merge everything in one go, right? You can, of course, prepare everything in a way where you're saying, okay, let's just take the variables we need and merge those, right? So you say merge one to many, keep using doctor qualification. I don't know, something like that, right? But what frames can help us do is that it allows us to load each of these data sets in different frames. So you have co-loading the data sets, and then you're picking the variable from each data set as needed without having to create a huge merge, right? Without having to just duplicate these observations 100 times or these observations 10 times to create one massive data set. And this can start impacting your memory load, right? So if you have, I don't know, like my work PCs is okay, yeah, it cannot handle 2 million data points, right? And so these kind of optimizations can also help you do analysis faster and stuff like that. And so frames can help us with that. And so basically what frames is allowing us to do is compartmentalize our different data sets into different frames. We will see how this looks like. And then we can use these different compartments to do different types of things, right? And so not only can we work with multiple data sets at the same time, we can also do interesting things like push subsets of data sets into new frames, do analysis, pull back the results, or we're doing 50 regressions. You know, with Stata, each regression creates all these tables and return variables. And it's always a pain to deal with this. We can push these results to frames and then just use a results frame to plot the results. And this makes already life much more easier. So these were all my 4 slides. So that's, I just would like to, then we can go to the Stata part, right? So I'm not going to do load any fancy stuff. So we'll just use whatever exists in Stata. And so let's start with this, right? So you start with an empty session, right? So you say clear. Yeah, you also have this command clear frames. Let's get rid of it, right? So this is your starting do file, etc. Right? And so if you type the command frames, right, you will see this frames. Current frame is default. Let me make the font bigger. So if you have newer versions of Stata, you're already operating in a frames environment, right? And if you say frames directory, it will tell us our frame directory that we have our default frame, which has a dimension of 0 by 0, right? Now let's do something. Let's say we say sys use auto, right? So this is the most common data set one uses. And we have loaded the data set, right? So this could be your system-based data set. This could be anything else. And you've just loaded this in your sim. Now, if we say frames directory, yeah, it will say that the default frame has this dimension 74 by 12, and this is what this looks like. And if we now just type frames, yeah, it will tell us that we are in this current frame. It's called default. So if you're using a new version of Stata, you are using frames, even though you might not be aware of it. And you are always in the default frame, right? And this is something you should always remember. So regardless of what kind of analysis you're doing, new versions of Stata, your analysis always exists in a specific frame, right? And now we can do many cool things. Yeah, we can say frame rename default core, right? So what we've done is we've renamed our default data set into our core. So, you can have frames. Now, if I type frames, again, the command, yeah, it will say current frame is core, right? So we are moved from using the default name to a custom name, which we called a core, right? And now let's say we were working with a data set and we need to start partitioning it. We can do lots of different things. We can say frames put make price mpg, let's take weight into my subset, right? So what we are saying is that frames put these variables into a new frame called my subset, right? And if you run this, Stata does not tell you anything, it just executes the command. But again, if you type frames directory, you will see something like this, that you have your core data set and you have your my subset data set. So basically what you've done is you've created another data instance, right? In which you have put your data subset that you can do some regression, right? And so this is again something that's not very, very visible, because this does not tell us anything in terms of saying something like, okay, frame subset created with so-and-so variable. It's something we've discussed with StataCorp to give more information when frames are created or modified, right? But you can see this asterisk sign in terms of subset. It says frames marked with this contains unsafe data. So how do we switch? Yeah, how do we switch between this? So we are in this current core frame. This is where we are. We can say frames. You can use frame or frames interchangeably. You can say frames change my subset, right? And then now we are in this frame. Now, if we just type frames, we'll get this information which will say current frame is my subset. And here you can see it's a small set of variables, right? And so again, this is something that if you're not very careful with, in Stata currently one has to track which frame you're working with. It's the same with working with maps, which use 2 frames per map layer. So always check if you're not sure which frame you're in, right? Let's go back to our core frame. We say frame change core. Yeah, we now go back to our core frame. We can do other things. We can say frames put. So let's look at this variable. So we have this variable foreign, which is domestic and foreign, right? So it's a variable which has a label. So 0 is domestic and foreign is 1. We can even say something like frames put if foreign equals 1 into foreign, right? We can say create a new frame where you're just taking this condition if this equals 1 into foreign, right? And so we have created a new frame based on a specific condition. If we again write frames directory, we will see that we have now 3 frames: our core frame, our foreign frame, which has fewer variables, and our my subset, fewer observations, and my pub subset, which has fewer rows, right? And you can keep creating these frames as many as you want, right? And there's a lot of, once you start partitioning your data into all of this, you can start doing a lot of cool things with this also, right? In terms of passing on commands. So now we are in our core frame, right? Which is core. So let's say you want to do something basically describe, right? So you want to do describe, or you want to do summary statistics or regressions. This is our core frame. Now we can also describe the variables in other frames, right? So we can say frame change foreign, and we can say describe. and we'll get something like this again, or let's say summarize, right? Summarize. So this is the summaries we get. We have 22 observations and we say something like that, right? So you can switch between frames and you can do different things in different frames, but you can also just stay in your core frame. And if you know exactly what you do, you can have this new prefix. You can say frame foreign summarize, right? So basically you can summarize other frames without having to actively switch, right? And so that's important to understand that once you create a frame, you don't need to switch every time. You can just do something like this. You can even say for each X in core, foreign, and my subset frame X summarize, right? You can even loop over frames without having to do anything like this. And you can say display in white frame X, right? So let's run this. So you can say we have frame core, this is our summary statistics, frame foreign, this is our summary statistics, frame my subset, these are our summary statistics. Yeah, and this can be replaced with anything. This could be replaced with regressions, yeah. And so this is a single line command. If you want to do something similar, you can also do other things. Yeah, you can also put this in a block. You can say frame foreign and just build a frame block, right? So you can just build a frame from, you can say for each X of var list underscore all summarize. So what we want to do is we want to go in the frame foreign, and in this frame we want to loop over each variable and just summarize it, right? And this is what we get. So we can now block, use either we use single line commands to return something, or we can use blocks to single frame operation, and we can say frame block operation. So we can either use single line commands to return something or execute something, or we can use a frame block and return, do a bunch of things. So it could be in this frame, run these regressions, right? And so think about it this way. If you have a very large data set that you're partitioning by different variables, so it could be hospitals or districts or schools or if conditions, you can pass on each into a specific frames and do a bunch of operations in a loop, right? The alternative would have been in the old workflow is to use preserve and restore. So you would say something like keep if this, do these operations, keep if that, do these operations. And that's something that is now sort of now redundant, because if you now use preserve and restore in Stata, so if you use preserve and restore in Stata, these two commands by default in newer versions are using frames. So if it's not like in the new versions of Stata, it's physically making a snapshot of your raw data set, dropping the variables. In new versions, Stata is actively creating a new temporary frame if you use preserve and restore and passing these operations. And it has led to a huge speed increase in certain operation, right? Okay, so this is sort of the core of the frame element. And there's quite a lot of stuff you can do. You can even say frames copy, frame copy core my frame, right? You can even copy or new code. Let's just go. So you can even copy your frames directly based on your use case scenario. So let's look at this. And so what we are now doing is now we're just creating a bunch of new frames that we want to use, right? we can also do things like frame create other data, right? So you maybe want to load another data, maybe either to temporarily look at some stuff or you want to do something else. And if I now do frames directory, you will see that we have now a new frame other data which is empty, and we can use say something like frame other data sys use census, right? So we have now loaded a completely different data set in another frame without impacting everything else. And this is super useful. This is super useful if you're working with multiple data sets, or let's say a common example is that I'm merging two data sets on country codes, yeah, on ISO 3 codes. And these ISO 3 codes have all sorts of variations. So instead of loading one, checking what exists, instead of loading two, the second one checking, I can parallel process these by just homogenizing these two data sets at the same time, right? And this makes also life a lot more easier. So this is all sort of up till now is what we will call the core usage. Yeah. So this is just the basic usage of how to deal with frames, switch between frames, or call database frames. Now let's look at an actual example, right? So let's look at the example that we sometimes deal with, right? Which is pushing results in another frame, right? Because this is something that we struggle with quite a lot. So let's clear everything. So you can either say clear, or we can say clear frames. Clear. Let's start with a clear blank slate. There is a command clear all, which clears everything, but I would just be careful. Yeah, with clear all, it really wipes everything off from the memory. So let's start with this, right? Now we have got rid of everything. We have nothing. We are back to our default, right? Now let's use load our data set in here. Just use auto or any other data set. And let's say we do summary statistics of some variables, summary statistics of values, right? So for each way, let's not do the deal, right? So for each variable, we'll get something like observations, mean, standard deviation, min, max. So add price, weight, length, right? And so quite a lot of times this kind of stuff needs to be used or pushed into tables, or you need to create different things. I don't know, like weighted price or unweighted price. So there's a lot of this summary statistics handling that needs to go into this, right? Uh, let's see how we can push this into a new frame. So we say frame create some summary statistics. Yeah. And in this summary statistics, we want to push three variables. We want to push the variable name, and we want to push the mean and standard deviation, right? So we want to create a variable summary statistics called summary statistics, which contains three variable names. Variable, a variable called variable. Let's just call it mean, so it's not confusing. A variable called name, a variable called mean, and a variable called standard deviation. Now, by default, Stata creates everything as numerical variables. So it's basically doing something like gen name equals missing, right? But what we really want to do is do something like gen generate name equals as a string variable. So this is something we need to do manually. So we basically say gen name string. You can say numerical or double or something like double mean st. This you don't need to specify, but for string variables, you do need to specify, right? In which order they are created. You can even have a list, but if you want a specific order, you can say name, mean, standard deviation, something else, right? Another text. So then you need to do this manually, but you can have a string and then reorder variables later on. So let's do this. So we have now, what is it? Unhappy about string variable double mean stay. maybe it needs a specific thing. Yeah. So you need to specify the length of the string. And now if we say frames directory, we'll say that we have a new frame called summary statistics. It has 0 observations and it has 3 columns, right? Let's check it quickly. Frame change some stats. And if we browse it, we'll see that we have 3 variables. It's string. This one is numeric. It's already as double, etc. Right? So this is already empty variables, right? Let's go back to our frame change default. Let's go back to our main frame. Now, what we can do, right, is we can push our summary statistics of these variables into this frame. Now, because you can only push summary statistics line by line. This is something, wait, let me just check quickly. Let me add 1 or 2 variables. So we can add headroom and trunk also. Okay, let's add headroom and trunk. Headroom. Right. So we use these 5 variables. So you can push your results to frames line by line currently. There's one exception of putting a whole matrix as it is into a frame, but currently it's line by line operations. So let's say for these 5 variables, we want to move the mean and standard deviation into a new frame, right? So you will have to write a loop for this. You will have to say something like for each x in 5 variables, right? Let's check if the loop is working. So for each x in price line, wait, okay, it's working. What we want to do is we want to summarize x. Let's see if this is working. So for each variable, we get the summary statistics. And so once you do a summary statistics, it will return your variables in all are locals or scalars in this case. So what we want is we want the mean and the standard deviation copied into the other frame. And then what we will say is that we will say frame post name of the frame, which is called summary statistics, is the name of the variable. Because it's string, we need to put it in double quotes. And then we say our mean and our RST, right? And so let's check this. Let's check this if see it works, right? So we run this. And so again, frames is not showing us any output, but if it's not giving an error, it has worked. Now let's go to the other frame. We say frame change some stats. And now if we browse, we will see that our variables and summary statistics have been added to this, right? And this kind of stuff, so for sure, there are lots of ways of exporting stuff directly, right? So there is a whole est tab command, you have the status own collect commands, you can of course do this. But let's say creating a table or a data set of summary statistics or any other sort of stuff that you can extract makes life a lot easier, yeah? And this didn't have to be summary statistics. It could have been min, max value, confidence interval, upper bound, lower bound, skewness, kurtosis, etc., right? And so you have now a subset of your data set which can be used to do other things. I don't know, maybe you want to visualize this, or you maybe want to export this in a table, and this is way easier to work with than your raw data set. So let's go back. Let's go back to your frame change default, right? And so you can automate this also in a script, because if I now run this again, it will append everything frame some summary statistics list. Yeah, so it has appended everything again. So you can just do something like this, which is say capture frame drop some stats. Yeah, so in your scripts, you're basically making sure you're starting with a clean frame. And so you just drop the frame in your script. You just create it from scratch to make sure you're not keep on appending results to your frame. So, just a minor check in your workflow. And so this kind of stuff helps us a lot in collecting variables from summary statistics or other kind of operations. You could be doing t-tests between two variables. If you do you can do t-test price by column, right? So you can do a t-test. You can see you get this output. You can return the list. You get all sorts of statistics. Maybe you need these statistics for something, for some reporting or something, or you just export this to your data. There's a lot of tests. Typically, I do on to check for outliers and stuff. You can create a data sets of flagged variables, for example. So you can automate the process where you say, okay, this variable in this row has some weird value. Now let's automate this and check these 100 variables or something. Yeah. And this is a very, very useful way where you are combining, where you're exporting results from one data set to another, right? The next example, which is, let's say, also very common, regressions. So regressions, again, can become very painful to deal with. So if you're not doing standard OLS type stuff, if you're doing more advanced analysis with other types of regressions with newer packages, dealing with outputs can become super challenging, especially if the packages are not programmed in a, let's say, generic way. Let's start with a blank slate, clear frames, right? Let's start with the blank slate. And then let's use something. I'm just using a very random example, yeah, which is with very random use NLS. Very random regressions, which are almost meaningless, right? So we are not doing anything exciting. So this is a panel data set that comes with Stata NLS work. So it's whatever has a person ID and a year. You can declare it as a panel data set. You can say xt set ID for year. And you will see that it's a fully balanced, it's not a fully balanced panel. It has 68 to 88 data observations, etc. Right? So you have something like this. So describe, if you do xt describe, it tells you how much of the unbalance exists. So for example, you can see that 138 observations have 1 year missing, so much of other years missing. Plus there are other patterns. So it's a very unbalanced data set. Okay, that's not the point. So we're not doing panel regressions. Let's do a sample regression, right? Like we say xt regress. This could be panel regression. It could be any regression. So we say ln wage. We say we regress log on wage on grade, age, tenure, like so, right? So we do a regression, right? It did not find. I'm so sorry. Let's just focus, right? So we do a panel regression, we get some out, right? Now, since it's a panel regression, we can do a fixed effects model. We can do a random effects model. We can do MLE model. So again, just with a simple panel, we can have different clustering of variables. We can have different controls. So let's say once you start doing regression analysis, you're basically testing quite a lot of stuff, right? So you're testing quite a lot of stuff, different specifications. You might add a square term, etc., right? And each regression is generating all of this stuff, right? So most of this is good for eyeballing what you're getting. So most of the time, we don't even look at this stuff. And then you're also for each regression generating things like you're generating an R table. So it's a table, which is a table of all your coefficients and stuff, right? And now what we want is that we want each of these regressions to be pushed, the whatever the coefficient and the standard error to be pushed into a different into a frame. Yeah. So let's set up a basic workflow. Again, this is a very context specific workflow, but this is just to give you an idea of what you want to do, right? So let's say capture frame drop results. So we just make sure we don't have a frame called results. We say frame create results, and we want two descriptive variables. We can say string 15. We want the model, and we want something like variable. So these are, so model is something, whether it's a fixed effects, random effect model. We want another variable which tell us the variables whose coefficient we are interested in. And then we want mean and standard error. Yeah, so you can leave it as it is. You can define the precision. By default, it's generated as a float. So let's create this frame, right? And then if I do frames directory, we will say we have 4 frames. And if I say frame results list, it's empty. Describe. We have 4 variables, which is model, variable, mean, standard error, right? So currently there is no observations, but we have now created an empty frame which has these variables. Now let's start with our one regression. So let's say we run a regression, we get this. And so we can just basically, let's just do it more efficiently. So we can say local independent vars. Let's just say our independent variables vertex, right? So we are now going into a more efficient workflow. We are not copy pasting hundreds of variables. We are just saying, let's just define a local one, right? And we can do something like this, all right? So we got something like this. We have our independent variables, which we define as a local string, and we just pass this on. Now we can say for each x in with independent vars and also our constant, we say frame post results. So post it in the results frame. So we have 4 variables. The first one is a fixed effects model. So that's what we want. The second variable is a variable name. And then, like I said, if you do e return list, or wait a second, return list. Yeah, that list table. We have these information stored in these locals, right? And so there is a way that Stata fetches this information, which is basically saying that we get the beta value of x and we get the standard error value of x, right? And so just to go over this slowly, right? We say we define these independent variables, so we can have multiple locals with different types of independent variables that we are passing on to this regression. It's just doing this. And then we are saying that for each of these variables plus the constant, right? Put the model name, fixed effects, put the variable name, put its beta coefficient and its standard error in our frame. So let's loop this in one go, right? Because we have a local, we run this in one go. And again, we get no information from the output, but what has happened is that our results from our regression has been posted in this frame for the variables that what we were interested in, right? Of course, you can export other things. You can export 50 other things from all of this. You can export the correlation coefficient. You can export R square, F stat value, etc., right? And now if I go to frames, change results, this is what we see. This is what we see in the sense that, so one variable was omitted. That for each, so we have the model, fixed effects model, and then we have the variable, its mean, and its standard error. And you can also export other things like upper bound, lower bound of the confidence interval, t-stats, p-value. You can then convert p-value into significance levels, etc., right? And so we can now replicate this process. Let's go back. Frame change default. And now we can replicate this process, and just all we have to do is basically say we now do this with random effect. We say random effect, or we copy this and we say MLE. And if you're already an advanced user, you can also loop this part in saying, let's run a model with all these subscripts. And so let's say you can do all of this. Let's just do this all in one go. So all random stuff. So this is our results export block, in which we start from scratch, create a frame, define our independent variables, and for each of these independent variables, we run different models, right? So this is just an example, right, which is very case specific to the stuff I'm presenting. But I can tell you that once you have this kind of stuff set up, this is it. Now what we have is for each regression model, fixed effects, random effects, MLE results, we have now a very neat table of our regression results, which are fixed effects, variable results, random effects results, etc. And once you start creating this kind of stuff, you can start doing quite a lot of interesting things, in the sense that we have not destroyed our raw data set. All we've done is that we are now pushing all our results to a new frame without having to, replace our original data or do crazy types of export combinations for our result analysis, right? And so this kind of workflow helps a lot with all of this, right? And there's also other things that you can do, right? So you can say, let me just show you another example. Let's just take the vanilla regression, right? So we are not interpreting the coefficients, but this is for your result. As I said, if you do return list, it shows you this matrix has been saved, and you can say matrix list R table. This is a matrix. So this is a matrix that contains everything, right? And it has a matrix that has all of this included. Yeah. And we can also export all of this. So again, I'll share the do file with you guys, so we are not wasting time on discussing all of this. But you can create something. I'll just copy paste this from my file library. So we can also export stuff because we have an index, we have a matrix with specific indices. So you have grade, age, tenure, south. So if you say matrix list R table, right, you get this. But you can say matrix R table 1, 1, or tables 1, 1. Oh yeah, you need to say display, which is weird. It should be able to do this. Okay, in any case. So basically you're saying display the first element of this matrix, which is a beta coefficient. And if I say display the second element of this coefficient, we get this variable, right? And so there are quite a lot of user-rated programs which are generating these matrices of results, and then most of the time you have to deal with these indices. So you have the first row is your beta. In this case, in the default Stata case, maybe you need the lower bound, upper bound, or you want the critical value of all of this. And so again, you can automate this process, which means we are creating a new frame called index in which we have the variable name, mean, standard deviation, lower bound, upper bound of the confidence interval, right? And then basically what we are saying is that once we run this regression, let's do this again. Let's run this regression again. And then basically we can say something like this. For each x in these variables, and we also add constant. So I'm not doing the other loop. We say frame post index test, the variable name, which is this. Then we need the mean variable, right? So we have the mean variable, which is R table 1, 1. So R table 1, 1. Then the standard deviation is the second variable, 2, 1. Then the lower bound is our fifth row, and the upper bound is our sixth row, right? But these numbers are changing. So if you look at our table, so we want grade is number 1, age is number 2, tenure is 3, 4, 5, right? So we are looping over names, but this index is going in numbers. Again, this is a slightly complex example. So we can say local I equals 1. We replace this with I, and also I, right? So which means it's saying that if we use grade, I equals 1, right? We want to say that if it goes to age, I should be equal to 2. So we can do two things. We can say local I is equal to I plus 1. So if we increment this, for grade takes 1, age takes 2, tenure takes 3. So the indexes are homogeneous. Or a more nicer way is you just say local plus plus I, which is, let's say, a nicer way of incrementing everything by 1. Yeah, we use this in programming all the time. So this is another example. Let me just show you what it looks like. B to be bound in parentheses. Okay, something is not happy. So we are missing a bracket here. Correct bracket. Correct. Right. So yeah, again, we get no information if it worked or not, but since we get no error, it worked. So we can say we can now do frame change. Yeah. And we look at this, we will see that our coefficients have been exported to these frames, right? And again, this is one example of how one can do with this. Again, if you are already advanced enough to be doing this kind of loops with locals and stuff, this is relatively easier to adapt to your workflow. But this, to me personally, has been the biggest plus point of frames, in the sense that we have been able to export results to a different frame without having to modify all this. And then you can play with these results, you can visualize them, you can plot them, you can use even in quef plot, etc., which is used a lot for, you can use this kind of results to plot your data sets. It also helps you organize your results. So you can have a model run, you can organize by model, you can organize by coefficients. It just makes life much more easier. to visualize these results. So the last thing I would do that I would like to work with is how to link frames. Yeah, linking frames. And so this is already the main thing that should be that you can use quite a lot. So we start with completely blank slate. We use web use family. So it's a Stata data set, and it's a very interesting data set, right? It's an interesting data set in the sense that it has two variables. You have a person's ID. So let's take this person, 14982. Let me make this bigger. So you have a person ID 14982. And now this person has a mother and a father whose IDs are also attached. Yeah. And this person, the mother's ID. So mother also exists here in row 431 because she also has her mother and father. So the grandparents of your first person. And this kind of data sets are fairly usual if you're doing ground survey analysis where you're doing village surveys or community surveys. And so this is the data set in which a person is being explained by another person who also exists in the data set, right? And so let's see how we can use frames to deal with this. So we can say frame create family, right? So we create another frame and we say frame family web use family, right? We reload the data set as it is in another frame, right? What we are then basically saying, if I do frames directory, we have two default frame and a family frame, which are exactly the same because we've just reloaded the data set in all of this, right? Like I said, and so what we will do is, because we have this person, let's take this person. So we say something like list PID star if PID equals. So this is the person ID whose mother's ID is this, whose father ID is this, right? Let's take the PID of the mother, right? So we do this if this, right? So this person whose observation number 8 is linked, whose mother exists on observation 431, right? And then this mother, this person's mother, right? So let's look at her. Let's look at her. She also has attributes defined in these variables, right? So, and you maybe want to add these attributes back to your original person. Maybe it's the, I don't know what this variable stands for. Maybe this is the income or education level or qualification, etc., right? That is affecting other outcomes of our person of interest, right? And so this is a complex data set in which we have sort of like a many-to-many kind of comparison in this data set. So what we are saying is that we will create a link. So we say fr link many to one, because the person can exist multiple times, on PID underscore m, because this person could be a mother to multiple people, right? So it's a many to one. And then this PID m from our main data set, we link it to the family data set with PID. And this is different from a different other merges with Stata, in which the variable needs to be exactly the same for you to merge it. In here, what we are saying is take this variable, yeah, which could contain duplicates, which could contain missings, but merge it in with family with the PID variable. Yeah, so we are merging variables with two different names, which you cannot do in a standard Stata merge. And then basically we say generate mother. Okay, and so we basically generate this variable mother in which we say that, okay, this person's is linked to ID 431M. So we know this person exists on row 431. And similarly, we can do the same with the father, and we can say father, right? And so we'll get the IDs of the mother and father, and then you can do quite a lot of things, right? Once you have generated this information, right, you can use this variable called frget. You can say frget, get the mother's mother, the grandmother information, equals eid underscore m mother. So basically what we have done is that we have now said that first link the two data sets in which we are getting the information from the variable mother. And then we are saying use the information that we have generated, get the mother's ID from this row, right? So which is again this column, but for this observation. So again, one needs to wrap one's head around the logic of this, but we are now doing much more complex merges across frames by linking them together. And this allows us to do many other things, right? So we can also get variable names. So we can get x1 to x4 of the mother into this variable. We can get x1 to x4 of the grandparents. And then we can start building more complex data sets as we go on. Yeah. And then the last example I want to show you guys is how to generate variables. So I will do something very generate variables based on another frame, right? So here we are linking, and I will just show you a simpler example, so which is not as confusing as all of this, right? So we clear everything. Let's just do clear all. We use sys use auto. And then we basically say gen ID is equal to underscore n. So we have a unique ID for each row. And then we say, right? So we have ID for each row. This is unique, right? And then we say frame put ID into another data, right? So this is, we just generate a new frame into the fly. We say frames directory, and we will say we have our default data set here, and we have another data set here. Yeah. Frame change another data. The only thing common between this data set and the other data set is the ID variable, right? And so this is just an example. So we say frame change default. So what we do is we say frame other data. Let's just generate some junk variable, some random variable. So we just do it in a block. We say gen x1 equal to r uniform. Gen x1 is equal to r uniform. Gen x2 is equal to r uniform int, right? So r uniform int is just giving you an integer. So double generate this. And so another data, sorry. Invalid syntax. Frame another data, gen double x1 equals to r uniform. Int. Normal, why is it unhappy? So, okay. Okay, something it's not happy with something. I don't know what it is. Let's just do it. X is equal to R uniform, R normal. If frame change another data, we have this. So R uniform int. Oh, I see. I see. You need to define a range. You need to define a range. So you can define something like, yeah. Okay, let's do it this way. Okay, now it works, right? So we have now generated two variables, some random variables. This could be an actual data. So if I say frame another data, summarize, we'll see we have the ID variables and we have some random normal variable and a uniform generated variable, which is from 1 to 10, right? And so again, we can do something like this. Fr link 1 to 1 because it's a 1-to-1 merge. ID frame other another, right? So all observations matched, and then we generate this variable called another data. So this is, so if I do summarize another data, this is a variable generated with this by Stata that helps us link this to the other variable. So we do not modify this or change this. Yeah. But here's the important part. We can say generate underscore link. Tab underscore link. It will tell us which observations were linked. So this is our link variable, right? And these two variables, which are system generated, one should never touch or modify. Again, you can read the help file, but these are variables are which is telling us what's linked to what variable. But that's not the point. So in the other data set, we have these two variables, x1, x2. We can say fr get x1, x2 from link. And then we will say this has been copied to from linked frame. So we can copy variables from the other frame. We can even do something like fr2, fr get x1, x2 is equal to x1. Sorry, let's so we can also do something like this. So we can say prefix underscore copy. We can also make sure that we are not duplicating stuff. So we can also prefix a copied variable to just to track them more easily. We can even do something like gen new var equals price over frval underscore link. So this is our link variable, and then we get x1 from the other data set, right? Fr value. And so we can not only copy over variables from linked frames, we can also pick up specific variables from linked frames and bring them over. And so again, going back to our initial example where we were looking at how to link different data sets. So this helps reduce the complexity or the size of the data set by just linking frames and pulling in the observations we need, right? And then again, if I say frames directory, we know that we have two frames. We can also save all this information. We can say frames save. We call it all my frames. This is the name of the save we get. Frame underscore all. These are also linked and replaced. And so what we do is we store this whole session, which we creates this DTAS file, which is a new file type. that helps us save our, let's say, session. Yeah, what is called sessions in R or similarly in Python is this session is saved, and then you can load this session. You can say frames use all my frames here, etc. And this will load your linked data sets and everything in one go. You can add frames, remove frames from this. There's a lot more one can do. And so, yeah, this is, let's say, a quick overview of stuff you can do with frames. Of course, it can get way more complex or way more interesting depending on your case. But the idea here was to showcase to you guys different ways of using frames for your workflow analysis.